Sorry about that the internet at school went off, and so the video ended rather unexpectedly. So back to question number 8. 40-kilogram box being pushed across the floor with the force parallel to the floor. Coefficient of friction is 0.25. Acceleration is 3 meters per second squared. And it wants to know what forces it's being pushed with. So we were just about to do some of the forces in the y direction to get our Fn. So it'll be Fn minus Fg equals 0. So Fn equals Fg equals mg. Okay, and yes, you can get a number, and if you want to get a number here, it would be 40 times 9.81, 392.4 newtons. Okay. You're looking for the force you're pushing with. You could also find your friction before you go there. You could do mu Fn. So friction is equal to 0.25 times this 392.4 newtons. And when you do this, you get a force of friction of 98.1, I think, newtons. Okay, so once you do that, then you go to sum of the forces in the x is equal to max. So F minus friction is equal to max. So you're solving for F, so bring your friction over. So F equals max plus friction. M was 40 kilograms. A was 3 meters per second squared plus the 98.1 newtons you just found. And if you wanted, and I was tempted to, you could just do all of this down here in the sum of the forces in the x. You could do mu mg and fill it in. 120 times 98, so that should be 218.1 perhaps newtons. That is number 8. Number 9, curling stone. Okay, so acting down is Fg. My paper slanted, sorry about that. Acting up is Fn. Throw in with an initial velocity, so Vi, 14 meters per second. It travels delta D, 49 meters before coming to rest. Vf is 0. With what is the coefficient of friction? So friction will be acting backward, and remember, on a curling stone, nothing is acting forward once you release it. So first step is to find A. Vf squared equals Vi squared plus 2A delta D. So A will equal Vf squared minus Vi squared over 2 delta D. Vf squared is 0. So negative 14 meters per second, and that gets squared over 2 times 49 meters. A ends up equaling negative 2 meters per second squared. Okay, we can do sum of the forces in the y next. Is equal to may. This curling stone is not moving in the y, so it'll be Fn minus Fg equals 0, so Fn equals Fg, and this time I was not very nice. I didn't give you an m. You can't get a number even if you want to. So you have to go to sum of the forces in the x is equal to max. The only force is friction acting backwards, so minus friction is equal to max. Of course, we know that friction is fun, so it's mu Fn is equal to max, and we know Fn is mg. So negative mu mg is equal to max. The m's will cancel, so it's okay that I didn't give you the m. You're solving for mu, so divide by negative g. The a was negative 2 meters per second squared. The negative g is 9.81, and it's negative as well. So you should end up with a mu of 0.20387. Okay, that was number 9. Number 10. A 20-kilogram box is being pulled across a level floor with a force of 120 newtons. Acting acting upward at an angle. So finally, we get to some angles. Okay, so acting upward at an angle, and it told us the force was 120 newtons, the mass was 20 kilograms, acting down is Fg, up is Fn, backward is friction, and of course there are two component forces here, Fy and Fx, and the angle is 30 degrees. The acceleration of the box is 3.5 meters per second squared, and it wants to know what is the coefficient, what's mu. Okay, so you might want to find your two components. The x is the adjacent side, so it'll be cos theta is equal to fx over f. So fx is equal to f cos theta. I would certainly be tempted to stop here and fill the numbers in later. If you didn't, fx is equal to 120 newtons, cos of 30. Fx is equal to, it's not going to be pretty, 103.923 newtons. Okay, I wouldn't do that here. Sine theta is equal to Fy over F. So Fy would be equal to F sine theta. Again, I would stop at this spot, but for those of you that just can't help yourself, 120 newtons sine of 30, this one will be prettier. Fy is equal to 60. Okay, now we go and do exactly what we always do, sum of the forces in the y direction. It's not moving in the y, so this will be 0. There are 3, Fn, Fy, Fg. If we call up positives, then Fn and Fy are both positive, Fg is negative. Always solving for Fn, so it'll be Fg minus Fy. In other words, it'll be mg minus f sine theta. Yes, you can get a number here if you want. It'll be 20 kilograms times 9.81 meters per second squared minus your 60 newtons that you had up there. So what is that? 196 minus 60. So it should be 136.2 newtons. Okay, go to sum of the forces in the x direction is equal to max. So there's Fx going one way, friction going back, equal to max. Calling direction of motion positive, friction will be negative. Okay, so Fx is F cos theta, friction is mu Fn, and it's mu that we're trying to solve for. So take your mu Fn to one side, bring your max over. So it'll be F cos theta minus max equals mu Fn, and now divide both sides by Fn. Okay, so mu is equal to F cos theta was the 103.923 newtons, minus m was 20 kilograms, a was 3.5 meters per second squared, and Fn was 136.2 newtons. And you should get a mu of 0.24907. Okay, number 11. Probably run out of time. A box is being pushed across the floor with a force of 200 newtons parallel to the floor. So just to keep you awake, I went back to parallel. Fg, Fn, friction, and it says coefficient of friction is 0.4. Acceleration is 1.2. What is the mass? Okay, so again, sum of the forces in the y direction, and you're going to discover that Fn is going to equal Fg is going to equal mg, and you're not going to be able to get a value. Go to sum of the forces in the x direction. F minus friction equals max. F minus mu Fn equals max. I'm going to run out of time. F minus mu mg, because it's not at an angle. Take the mu mg over.